This is the periodic table. It's the one that has been taught in school, and the one that is in use everywhere throughout the world. But it hasn't always looked like this. Flashback to 1935, and the periodic table looked a little different. You can see it has a few missing spots, but here at the bottom, it is missing nearly an entire row and a half. These elements here are all of the elements that humans have found naturally. Some are in the air, some are in the ground. There are even a couple liquids. But in 1935, if physicists wanted to discover more elements, they would have to do something no one else had ever done: create, not find, a new element. This is the story of the race for the periodic table. As long as it has existed, physicists have theorized about creating synthetic elements beyond the periodic table. Throughout the Cold War, scientists at UC Berkeley and the Joint Institute for Nuclear Research in Dubna, USSR, competed to create new elements. This competition led to 13 new elements being discovered in just 30 years. The different scientists that worked on either team pushed the frontier of nuclear chemistry and particle physics. These discoveries were incredibly important because they helped to expand the field of nuclear physics and create many new inventions, from modern nuclear reactors to cardiac pacemakers. The discoveries completely changed history by helping to create the nuclear weapons which defined the 20th century. In 1934, acclaimed nuclear physicist Enrico Fermi claimed to have created a new element, one with an atomic number of 93, what we now know as neptunium. He had done this by firing neutrons at a uranium target, hoping to cause what is called a beta-minus decay. A beta-minus decay is a type of decay in which an atom with one too many neutrons transforms said neutron into a proton, electron, and an antineutrino. This raises the atom's atomic number by 1, potentially creating a new element. After the neutron bombardment of the uranium target, Fermi discovered 2 samples of elements not matching the chemical properties of any element going down to lead. Fermi and his team believed this to be the new elements 93 and 94. But Fermi had not discovered a new element. He had instead done something even more incredible. He had split an atom in 2. The first synthetic element was actually discovered 3 years later, when Emilio Segre inspected a sample of molybdenum which had undergone a beta-minus decay, creating the long theorized about element 43, technetium. This discovery would set the stage for all future new elements. The first transuranium element was discovered in 1940. By activating a uranium target with neutrons from the 60-inch cyclotron at the University of California, Berkeley, causing a beta-minus decay and creating a new element. But, due to the imminent war, both the discoverers of neptunium were forced to abandon the element hunt for the Manhattan Project. So, the element hunt would need a new captain.
So now you'll have to tell your teachers that to change the 92 elements in your school books to 96 elements.
This is Glenn T. Seaborg. In 1940, he was a simple chemistry major at the University of California, Berkeley. But, through a series of coincidences, Seaborg became the captain of the element hunt. And, in December of 1940, the team had an idea for creating another element, element 94. Instead of using a beam of neutrons to beta-minus decay the uranium target into neptunium, they would use a beam of deuterons, a hydrogen atom with 1 proton and 1 neutron. The idea was the proton would instantly raise the uranium target to neptunium, and then the neutron would have a chance at beta-minus decaying into element 94. And On December 14, 1940, plutonium was made for the first time. Elements 95, 96, 97, and 98 were made in a similar way. But before the Berkeley team had a chance to attempt to make element 99, another team at Los Alamos, in collaboration with Berkeley, discovered both elements 99 and 100 by flying a jet through the mushroom cloud of the first fusion bomb and shipping the material back to Berkeley. This presented a problem. While it is easy to create plutonium or americium, it is exceedingly difficult to create new elements using the same techniques. The odds of a reaction with any element is extremely low, such that Albert Einstein said, "It is something akin to shooting birds in the dark, in a country where there are only a few birds." Berkeley would need to step it up if they wanted to stay on top, because there was a new competitor. But competition always breeds innovation. For the past 20 years, due to the high cost of hunting for elements, Berkeley had been the lone runner in the element race. But now, thanks mostly to the work of one man, Georgy Flerov, the USSR founded the Joint Institute for Nuclear Research in Dubna. Just like Berkeley, JINR had the resources required to hunt elements, and now, with two teams hunting elements, a new discovery was inevitable, and in 1955, it happened. Instead of using a beam of neutrons, or deuterons, Berkeley fired a beam of helium ions at an Einsteinium target, and they fused, creating element 101. This technique would be perfected when, after firing carbon ions at a curium target, element 102 was discovered. But JINR had actually claimed the discovery of element 102 several months earlier, and while Berkeley's data was more reliable, having analyzed alpha decay chains, Berkeley's winning streak was broken. Using its head start, JINR managed to discover elements 103, 104, and 105 before Berkeley could react, leaving Berkeley to nitpick through their data, hoping to show better proof of the elements. But in 1974, Berkeley got one last element, element 106, named in honor of Seaborg. Despite their experience and their recent discovery, Berkeley's new team just couldn't manage to keep up with JINR. There was also a new member of the element race. GSI at Darmstadt discovered elements 107 to 112. But then, after 25 years of third place, it seemed Berkeley had discovered new elements. Not just a new element, but three. Elements 118, 116, and 114. But not everything was as it should have been. Neither JINR or GSI or the newest competitor, the Riken Institute in Japan, could verify these findings. Even worse, after looking through the records of the discovery, it was found that one handwritten note was the only evidence of the discoveries. All the rest had simply vanished. It was soon found that one Viktor Ninov had faked the discoveries. This spelled the end for element hunting at Berkeley. What should have been an amazing new accomplishment that breathed life into Berkeley's element hunt was actually what doomed it. Berkeley's element hunting team mostly broke up, forever ending the chances of Berkeley getting another element. While a lot of the discoveries made during Berkeley's streak were made mostly to push the frontier of the periodic table, many of their discoveries do have uses. Take for instance plutonium, which is now used everywhere as a fuel for both nuclear reactors and nuclear weapons. Another example is americium, which is used in almost every building in the world, as americium is a necessary component of smoke detectors. Even curium has been used to power thermoelectric generators in spacecraft, like the Cassini mission to Saturn. But some of the later elements, like 98, 99, 100, and 106, don't have a lot of use. They are simply testaments to the human spirit, proof that humans can't resist breaking into new frontiers.